Hello all, in today's video we are going to learn about the random access protocols CSMA, CSMA-CD. In the previous video we have learnt about another random access protocol, that is Aloha, which had two types, pure Aloha and slotted Aloha. We have seen that the pure Aloha and slotted Aloha, how they try to avoid collisions. Now we will learn other techniques of avoiding collision that are using the CSMA protocol and the CSMA-CD protocol. The carrier sense multiple access protocol, as the name suggests, it will sense the carrier. The station will first sense the carrier. What do you mean by the carrier? Carrier here, it means that it is a medium that is being accessed by multiple devices. So a station, before sending the data, will sense the carrier. If it finds the carrier to be idle, then it will transmit the data. If it finds it to be busy, then it will wait or refrain itself from transmitting the data. So here it is just like when you are crossing the road, you are looking to your right and left to see that if there are any vehicles coming around. If you find them, you will stop yourself. That will avoid accident. The same thing is happening here. The station will look for the channel. If the channel is idle, it will transmit, and if the channel is busy, it will not transmit. This will help us avoid or reduce the chances of collisions in the transmission media. Now let us see what is the vulnerable time in CSMA. If you remember, the vulnerable time in pure Aloha was 2 times the frame time. The vulnerable time in slotted Aloha was 1 times the frame time, but here in CSMA the vulnerable time is equals to the propagation time. The vulnerable time is equal to the propagation time. Let me tell you how. See, assume that we have station A, B, C and D connected like this on a single channel shared by multiple devices. Okay, so here the station A is, this is the time how the time is increasing. The station A transmits the frame at time t1. The first bit of the frame to reach or to propagate is called as the propagation time. The first bit might take, if depending on the distance between A to B, the first bit of A reaches B at this point. So B will sense the that the station A has transmitted the frame at this particular point. Likewise, for the signal to propagate from A to C at this particular time, C will sense that the A has sent a frame or the channel is busy, and D will sense it here. So if in this meantime, if in this propagation time any other station sends the frame, that will result into collision. But if the channel will, if the station senses the channel before transmitting, it can avoid collision. So this is the idea of CSMA. In CSMA, we have three very important access modes. We have three very important access modes. They are one persistent, non-persistent and P-persistent. What is the meaning of being persistent? Persistent is I am continuously trying to do something though there are a lot of difficulties. Okay, you are persistently pursuing your career, for example. Okay, so here persistent is to mean that the station will persistently, that is continuously, will be sensing the channel to see whether it is idle or busy. If it is idle, it will transmit the frame. If it is busy, it will refrain itself from transmitting. But as soon as the channel becomes idle, it will immediately transmit. This is called as one persistent CSMA. Non-persistent CSMA means that, as the name itself says, not continuously. The station will sense the channel. If it finds it idle, it will transmit the frame. and if it finds it busy, it will wait but will not continuously sense the channel. And again after some time it will sense the channel, and if it finds it idle, it will transmit, or it will wait again and then it will sense the channel. P persistent CSMA. Here P is for probability. That is, here P persistent is a combination of both one persistent and non-persistent CSMA, wherein P persistent CSMA, I am going to continuously sense the channel, and but I will, in this case, I will transmit based on the outcome of my probability. If I will transmit with a probability P, and I will not transmit with a probability Q, that is 1 minus P. Let us see these diagrams to understand them very clearly. In one persistent CSMA, the station is continuously sensing the channel and it finds it to be busy. If it is busy, it will wait, and as soon as it finds it idle, now it has become idle. The blue part, shaded part, means that it is busy. Because it is continuously sensing and it found out that it is idle, it will immediately transmit. But there's a problem here. There might be other station also continuously sensing, and as soon as it also finds it idle, it will also transmit, and that may lead to collision. What is non-persistent CSMA? As I told you, it will not continuously sense. It will sense, wait, again it will sense and wait if it is busy. And if you see, the channel became idle here, but it is not simultaneously transmitting as it finds the channel idle. It is waiting for this amount of time and then transmitting. So the number of collisions compared to one persistent CSMA and non-persistent CSMA will be, in non-persistent CSMA, the number of collisions might be less. When we come to P persistent CSMA, it's a combination of both one persistent and non-persistent. You can see the station is continuously sensing the channel, okay, but when it comes that the channel is idle, it will not transmit immediately. It will transmit based on the probability outcome. And if the probability outcome, it is not allowing it to do transmission, it will wait for a particular time slot, and then when again it will calculate the probability, and based on the outcome of the probability, the station will transmit the data. Here the number of collisions are less compared to one persistent and non-persistent. You can see here the flow diagram for three persistent methods. I am showing you all these three ways of writing the theory part, the diagram and the flow chart, because this is a very important question coming for the exam. Okay, so you need to know how you have to write your representation of the answer in the exam. You see, station in one persistent, the station will be continuously sensing the channel. If it is idle, it will transmit. If it is busy, it will again check, again check, again check, continuously sensing. This is one persistent. But when it comes to non-persistent, you can see, if it is idle, it will use it. If it is busy, it will wait for a random amount of time and then it will transmit, and then sense the channel and transmit. When coming to P persistent CSMA, what it does, if it finds the channel idle, it will wait for a probability outcome, and if the probability outcome is less than or equal to the probability P, it will transmit. If it is Q, if it is 1 minus P or Q, it will wait for a particular time slot and then sense the channel, and if it is idle, it will transmit. Okay, or otherwise if it is busy, it will use back off process as though collision has occurred. So these are all the CSMA persistent methods: one persistent, non-persistent and P persistent. Now coming on to the second method of CSMA, that is random access protocol, CSMA CD, carrier sense multiple access with collision detection. Here what happens is, it is a CSMA CD network protocol to transmit data frames, where the station will first sense the shared channel before broadcasting or sending the frames. If the channel is idle, it will transmit the frame and will check to see if it was successful. How will it check to see if it was successful? It will receive the acknowledgement. If the frame is successfully received, the station will transmit the other frame. But what if a collision occurs? What do you mean by collision detection here? In this, what we are doing, the whole procedure is same. We might be using some of the CS, we are doing it randomly, but we are using some persistent methods. We are sensing the carrier before transmitting, and most importantly here in collision detection, we are going to send a jam signal or a stop signal to on the shared channel, to so that to tell the rest of the stations connected to the multiple access channel, telling to refrain themselves from sending the frames, because there is a collision already, so you can stop sending your frames. So that is why it is called as collision detection. So when that jamming signal comes, it will wait a random amount of time and then it will send the frame on the channel. You can see here collision of the first bit in CSMA CD. As I told you, the vulnerable period is nothing but the propagation period of that particular bit of a frame. Now you can see station A has at time T1 found the channel to be idle. So it has sent a frame. By the time it has propagated to C, before that time only at T3 the signal of A has reached C, but before that time, that is at T2, C found out that the channel was idle and C also have transmitted the frame. But at time T3 the signal of frame A reached C and there was a collision. C detects a collision and aborts its transmission. Likewise, the frame of C, the first bit of C to propagate to A, it took time T4. So at this time, the signal, there is a collision here. The bits of A are colliding with the bits of C. Not exactly here. They are colliding somewhere here, because first when A started transmission, C did not know about A, and when A started transmission, A did not know about C. At a later point of time, there was a collision, and due to this collision, what happens is the stations will send a jam signal on the channel, telling the other stations to get alert that there is a collision and they can refrain from sending the frames. Now, as I told you, what is the backoff strategy? Everything is same. We'll see the number of attempts will be initially 0. Here we will be applying one of the persistent method. Any one of the persistent method I will use, and I will see if I am eligible for transmission. If there is no collision detected, I will transmit and receive. But if a collision is being detected, what are we going to do? As I told you, the moment collision is being detected, we are going to send a jamming signal. And that jamming signal will make you to wait for a random amount of time. How is that random backoff time calculated? By the number of attempts. If K was 0, K now becomes 1, and the number of attempts we are making it as 15. If the number of attempts are less than 15, we will choose a random number between 0 to 2 power 1 minus 1, that is between 0 and 1, and like this we will calculate the backoff time. Backoff time is the random number into the propagation time, and the station will wait for that much time, and then again it will sense the channel using any of the persistent methods, and it continues. So here we are reducing the amount of collisions, and also we are doing collision detection. But how will the station know that there was a collision? As I told you, that every frame transmission, you can see here, this is the frame transmission. When we are talking about frames transmission, it is transmission of energy or a signal. So maybe this signal is 5 volts. The normal signal which is going is 5 volts. But whenever, and this is idle. Now nobody is transmitting, so this is idle. But when we come to see that there is a collision where two frames of different stations are colliding, there is a possibility that there will be a rise in the amplitude of the signal. This rise in the amplitude of the signal, that it may become some 7 to 10 volts, for example. This will result into a collision, and this will be felt by this extra heat or this extra voltage will be felt, and that will be considered as a collision. So this is about your other random access protocols, CSMA, CSMA persistent methods, and CSMA CD. Thank you.